Hello students, welcome back to Mathematics Lovers Club. Today we will discuss some questions from the coordinate geometry from the syllabus of edexcel IAL and the module P1. So here there is one question from the paper January 19th. So in this question, the equation of a line L1 is given, which is 3x plus 5y minus 7 equal to 0. You have to find the gradient of this line L1, and there is another line L2 that is perpendicular to line L1, and it passes through the point 6, -2. So you have to find the equation of L2 that is in the form y is equal to mx plus c, where m and c are constants. Now we have already done the linear equations. So if the equation is in the form y is equal to mx plus c, so Vicky, tell me in this equation, what does m and c represent? Sir, in the equation y is equal to mx plus c, m represents the gradient of the line and c represents the y-intercept. Correct, Vicky. Very nice answer. But the equation that is given to us is not in the form y is equal to mx plus c. It is in the form ax plus by plus c equal to 0. So, Mini, can you tell me what should we do to find out the gradient of the line? So, we should get the equation in the form y is equal to mx plus c. For that, we should make y a subject of the equation. So that means, in this case, we can write 5y is equal to minus 3x plus 7. So y is equal to minus 3 upon 5x plus 7 upon 5. So if we compare this with y is equal to mx plus c, the gradient of this line will be negative 3 upon 5. Correct, meaning very nice answer, and that is the solution of part A. The gradient of line L1 is negative 3 upon 5. Now, let us come to part B. So let us just sketch. So this is one line here, L1, and there is another line, L2. And given that both these lines are perpendicular to each other, so suppose the gradient of line L1 is say M1. Gradient of line L2 is say M2. What will be the relationship between the gradients M1 and M2 of the two perpendicular lines? Yes, Jenny, you please tell me. So, if two lines are perpendicular to each other, the product of their gradients is -1. That means M1 into M2 is -1. So, in this case, it is given that the gradient of line L1 is -3/5. Actually, it is not given, but we have found it in part A. The gradient of line L1 is -3/5. That means gradient of line L2 will be the negative reciprocal of this gradient, and that will be 5/3. Correct. Well done. So now we have got the gradient of line L2, which is 5/3. So what should we do next to find the equation of line L2? Yes, Akshay, please come on the board and show me the steps, what you'll do. Yes, sir. Now we have the gradient of line L2. So we'll write the equation of line L2 in the form y is equal to mx plus c. And we have the gradient 5/3 that will substitute for m. So y is equal to 5/3x plus c. And finally, the point is given to us. It is said that the line passes through 6, -2. So we should substitute this point in the equation. So y is equal to -2. That is equal to 5/3 into x is 6 plus c, which gives -2 is equal to 10 plus c. So c is equal to -12. And since we need the equation of the line just in the form y is equal to mx plus c, we'll just put this value of c in this equation. I'll call this as 1. So that means the equation of the line L2 will be y is equal to 5/3x minus 12, which is in the form y is equal to mx plus c. Correct, Akshay. Very nice try. The answer is correct. So in the next class, we'll discuss some more questions on the coordinate geometry from the past papers. By that time, revise the previous part of the topic I had already done with you. See you soon, students. Enjoy the day ahead.